Okay, so if we are trying to calculate the vapor pressure, can't talk today, from the boiling point and enthalpy of vaporization, what we are going to need to do is use the 2-point version of the Clausius-Clapeyron equation. So that is the natural log of your vapor pressure at one temperature divided by the vapor pressure at another temperature is equal to hang on, I meant to put the brackets up there. These are supposed to be big brackets, but this is the best I can do, is equal to the enthalpy of vaporization, so delta H of vaporization divided by the gas constant, R, uh, multiplied by 1 over T2 minus 1 over T1. So a few things. You want to decide what your T1, what your T2 is, and temperatures are going to need to be in Kelvin because we can't be dealing with like negative degrees Celsius, etc., right? That's just going to be a big mess. So let me go ahead and just put some lines on there to make that a little bit easier to read. Right, now it's a math equation, okay? So what I would go through and do is decide what T2, what T1 is going to be. And this is important information. It's normal boiling point. Our definition of normal boiling point is that a substance boils when its vapor pressure reaches the same as atmospheric pressure, which is 1 atmosphere or 760 torr. Now, I believe these questions ask for your answer in atmospheres. So if it was torr, we'd say 760 torr, but we're going to go with atmosphere, so 1 atmosphere. To make the math easy, I recommend using this version, the Clausius-Clapeyron equation. T2 is on the bottom here, so vapor pressure of T2. If that is your atmospheric pressure for your normal boiling point, that means you've got 1 atmosphere on the bottom there. Nice and easy to rearrange. So I'm going to say T2 is where your normal boiling point is, okay? So PVAP at T2 is going to be 1 atmosphere. Okay, and then T2, this is going to be that minus 131 degrees Celsius, but we're going to have to convert that into Kelvin. So we are going to add 273.15, which is going to give me 142.15 Kelvin. Okay, so we make sure that we have assigned that. So from this part of the question here, that is what we're getting. So normal boiling point. So that is going to be our T2. This is our enthalpy of vaporization. Okay, so that is our delta HVAP right there. And then this is going to be our T1 down here. So we've got to convert that into Kelvin as well. So T1 is going to be minus 159 degrees Celsius plus 273.15, which is going to be 114.15 Kelvin. Okay, so R is the gas constant, which is 8.314 joules per mole per Kelvin. That is a thing which we know or can look up. So we are also going to have to convert those units, 8.314 joules per mole per Kelvin. We can see our vapor pressure, enthalpy of vaporization is kilojoules per mole. So we're also going to have to use the unit conversion that 1 kilojoule is 10 to the power of 3 joules, which for me is going to be easier to type like that. So we're going to need to use that unit conversion as well. So when you're rearranging equations with natural logs, then you're going to do e to the power of both sides to get rid of that natural log. So what we're going to end up with is, please say that that actually copied and paste, yay. So if we do e to the power of both sides, that's going to get rid of that natural log. And you know what I can also do there? Maybe that's not going to be such a good idea. No! Okay, so PVAP over T1 on the left-hand side, and then it's going to be e to the power of everything on the right-hand side over here. So let's see if I can draw some rudimentary brackets in a different color, just e to the power of all of this, okay, is what we are going with there. So obviously that's a little bit messy to write, but so what I generally tend to do is take before we do e to the power of both sides and just calculate what the number on the right hand side is, because it's just easier to do e to the power of like one number, right? So I'm just going to go ahead and substitute numbers in on this side. So that's my 27 kilojoules per mole. Would help if I could type today. Divided by that 8.314 joules per mole per Kelvin. And then I'm going to have to stick in my unit conversion, so this is still part of the delta H vap over R. If I stick in my joules, kilojoules unit conversion, you'll see that that should take care of the kilojoules and joules part of that. The moles are going to take care of themselves, and the kelvins are going to be taken care of by the next part here. Again, you're going to want to be careful with like parentheses when you put these things in. So like 1 over T2 should be in parentheses. So that's going to be 1 over, what did we say, 142.15 minus, and again, this bit may need to be in parentheses, and then all of it needs to be in parentheses as well before you multiply by the delta H vap over R. So that'd be 114.15 Kelvin. So that's just going to come out to be a number on the right-hand side, and then you just do e to the power of that number, right? Where's my little liney thing gone? There we go. All right, so that, if I type all of this shenanigans in my calculator, I'm going to end up with, do I still have this? Yes. I'm going to end up with this equals a number. All right, so that number is going to be about, and it's going to be unitless, minus 5.603882. That's probably enough decimal places, sig figs or whatever. So if I do natural log of both sides now, so what I will end up with is just pvap T1. Come here. pvap of T1 over pvap of T2. And we actually know what that is, right? That's 1 atmosphere. Minus 5.603882, blah, blah, blah. So we can multiply both sides by pvap of T2 to get it off from the bottom there, okay? So we're going to end up with pvap of T1 equals e to the power of blah, blah, blah times 1 atmosphere, okay? So our units are going to come out to be an atmosphere, and I make that to be 0.003683 blah, 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 blah units of atmospheres. Looking at sig figs, we've got 3 sig figs in the question, though, so I would round to this, but then the question actually told us to round the answer to 2 sig figs. So 2 sig figs, we look at the 8, that is 5 or above, so we're going to round up. So to 2 sig figs, I'll leave that on there, 0.0037 atmospheres to 2 sig figs, like so. All right, so hopefully that is helpful. So when we're rearranging this, just remember to get rid of a natural log, ln, you just do e to the power of both sides. If you had a base 10 log, log, you would do 10 to the power of both sides. It's the same deal with a natural log e, but you do e to the power of both sides instead of 10 to the power of both sides. Okay.